Hi, I'm Steven Annunziato, and here's my submission for the midterm. So there's also interactivity here, so depending on where I click on the screen, it'll make the scene a little bit more different and a little bit more lively. Okay, so jumping into the code, first I have the common tab here. In the common tab, I have a couple colors that just kind of denote a universal color scheme for everything here. I have a couple data structures for ray tracing, so just shapes and hit records and everything we need for the rays and whatnot. And just a couple of utility functions that are used throughout the rest of the buffers just to keep things a little more simple. So the first part of the whole pipeline here is sampling the music, and I can get a visual up on the screen to show you how this is done. As the music plays, I can really just sample from the music as if it's a texture. And what I figured out is that, first of all, I just have to sample from y equals 0. You can sample from somewhere else in the screen, but I'm not really sure, to be honest, what the y component of the music is supposed to represent. So sampling the music at y equals 0 just seems to give a universal, or just like an easy way to get information from the music. What I found out is that at the very left of the texture is 20 hertz, or just sub bass, and all the way up to the top is 20,000 hertz, or just the very high end. And so by sampling somewhere in between, you can actually get the volume of a particular frequency at the time of playback. So using this, I go to the next buffer, which is the texture for the ground. And I can get that up on the screen as well. So to make this happen, I start with just finding a UV value between 0 and 1, and then I offset that by a sine function of the music. So what I do is I first find some value t, and I make sure that it's between 0 and 2 pi, so that the bottom and the top are always lined up with each other, making sure that the texture will be able to tile appropriately. And then I just increase the intensity of the sine wave based on this is sampled at 0.5, so just somewhere in the mid to high end-ish range. And so this goes back to the universal color scheme from the common tab. By changing that, you can kind of change the look of the whole scene. And finally, that all comes together to the ray tracing buffer. And this is really just kind of a combination of all the labs we've done so far relating to ray tracing. So I start out in the main image function, and I calculate the viewport information, and I first start by just sampling the music in a whole bunch of different locations to find values for the sub bass and the bass and any kind of frequency band that you would want to access. This kind of makes it really easy to send this information through the rendering pipeline, so you can really just implement and integrate the music into the visuals at any point in the rendering pipeline. There's also a little bit of interactivity here, so I use the mouse's interactive position to kind of just modify the values for animation. And this is just defining all of the different spheres that are in the scene, and it gets sent to the calc color function. So for calc color, there's 3 different sections here. First we have this little section for determining if the ray hits any spheres. We have this section for determining if the ray hits a plane. And finally we have just a gradient in the background. So implementing the plane was new here. So to start, I take a plane normal, and this could just be straight up, but I just animated it over time just to add another visual effect to the scene. And this gets sent to the plane intersect function. So quickly scrolling to that, here's the plane intersect function. This just returns a float which represents the distance from the ray origin to the hit point. So that makes it pretty easy to render in the plane on the calc color function. Let's go back to that. Here we are. So I also define the lights here, and I send the lights into this calc lighting function, and so the hit sphere array function and all the different methods of determining whether the spheres are hit are nothing new from the past labs. I kind of just put everything together here. So to briefly go over it, let's see, I have, here we go, hit sphere array. So this just loops through each sphere in the scene and determines if the ray intersects each sphere. And here's just a quick hit sphere function. This just does the actual mathematics to determine whether or not it's hit. And finally, once all the hits are determined and all the normals are determined, get sent into the lighting, the calc lighting function. And this includes Lambertian reflectance, just for the general look of everything. This includes Fung and Blin Fung specular highlights as well. When a sphere is hit in those functions, the sphere data type has its own color, so there's ways to kind of customize the look of each sphere as it's hit. So in terms of incorporating the music into this scene, I just kind of wanted there to be some way to see the music going on in this scene pretty much anywhere you look. So the most obvious one is just the wavy lines on the ground. Yeah, this is just showing how the music can be kind of taken into any of the buffers and how it can just kind of make its way into any part of the rendering pipeline. But the most important part of the music integration is probably about here. After I've determined all the different frequency bands, just finding positions for each of these spheres is the most important part. So I really just have one sphere in the middle, and its scale increases with the sub bass of the music. Just because that's a good visual indicator. It's something you can hear very well, so I guess it just makes sense to be the kind of center of attention. And the other orbiting spheres sample from the highest point of the music and the rough middle point as well. So those ones have a kind of similar sound to them, so they kind of look visually correlated as well, but you can differentiate between them in different parts of the song. That's all. Thank you very much.